All right, so I just wanted to go over the key a bit in case you had any questions, and just looking at the answers here. I didn't write out my answer for number one. What does it mean for reaction to be spontaneous? You should have said something along the lines of, it happens on its own. It happens without, we said in class, continuous help. Any of that works as long as you kind of know what that means. We're not pushing it along. The example we used in class of non-spontaneous would be like baking cookies in the oven, where as soon as you stop pushing that process along, it stops. So that would be non-spontaneous. So spontaneous would just be the opposite. Okay. For number two, basically you just had to calculate the delta G, which meant that you first had to calculate the delta H and the delta S. And for that, we just go to the table. And I am referring to the thermal properties table. So that would be this one, right? So we have our H values, our heat of formation values on the left, and our entropy values on the right. All right, so I just plug those in and I make sure I have a balanced equation. And actually for both of these equations, they were already balanced. So we didn't have any coefficients to worry about. And we just do products minus reactants. So if you messed up your signs, make sure that you did products minus reactants, not reactants minus products. So exothermic, if it's negative for delta H, I just noted increase or decrease, for the delta S, but you weren't really asked to do that. If it's negative, of course, that means delta S is going down. If it's positive, it's increasing. And then the most important thing is, once you get your delta G, if it's negative, you understand that that means the reaction is in fact spontaneous. So both of these were spontaneous, at least at the temperatures given, which was 298 kelvins. All right. Next up, number three, this was just a stoichiometry problem. You obviously know how to go from grams to moles, and then just understand that the negative 691 kilojoules that this reaction releases, or I should say the delta H being negative 691, the 691 kilojoules that this reaction releases, that is per 1 mole of magnesium nitride. It's also per 6 moles of water and per 3 moles of magnesium hydroxide and per 2 moles of ammonia, but this question is giving us information about the amount of magnesium nitride. So I would go from grams to moles of magnesium nitride and then use the thermochemical equation to determine that 1 mole of magnesium nitride gives me negative 691 kilojoules. So I get, in the end, since I don't have 1 mole of magnesium nitride, it only gives off 513 kilojoules. So obviously still exothermic. This next one is pretty much just an algebra problem. It says, using only the thermodynamic data given to you by Mr. Young, calculate the heat of formation of Mg3N2. In other words, the Mg3N2 is not on our thermal properties table. It's heat of formation, I mean. So if we go back to our little, heats of formation entropy table here, you will find magnesium hydroxide, right? There's its heat of formation. You will find water, you'll find ammonia, you'll find everything else in the equation, but you won't find Mg3N2. Now you could look it up. I mean, you can find these things online. But if you know the delta H overall for the reaction is negative 691 kilojoules, which was of course given to us up above, we can just basically set up delta H for the reaction equals products minus reactants. And one of the reactants we don't know, and that becomes my X. That's my Mg3N2. So that's what X represents. Okay? And then I just solve for X. So a little tricky sign-wise on this one. If you have to remember to kind of put the reactants in one big set of parentheses, because when you put this minus sign out front, if you don't have these parentheses right here, you're going to forget to distribute that negative, and it's just going to mess up your math, and you're going to end up with like a heat of formation that's like in the thousands. But if you remember that that negative sign gets distributed to the x and the negative 714.8, then that becomes positive, and then we can subtract it from both sides, and the problem works out. But you should be able to, just using, algebra, rearrange to get x by itself, and it ends up being negative 529.9. All right, and then the last problem, or two questions there, we're just asking you to predict delta S. So a candle burning, you're going from, well, I guess technically a liquid paraffin, the wax melts before it burns, but either way, whether it's a liquid or a solid, when it burns, the products are just gases. So that's why I would expect that to increase entropy. Butter melting, of course, it's a solid to a liquid, so that's going to become more entropy, or have more entropy. Ammonia vapor condensing, any gas going to a liquid should mean that we're becoming more ordered, less random, and therefore less entropy, so negative delta S. Tea dissolving in water, you're going from separate tea and water to being mixed. So anytime you're mixing two things into one, that means that we're becoming more random, because those particles are not separated anymore. They're together. They're well mixed. Then finally, number 5, looking at the equations, kind of doing the same thing. This process, I know, looks a little strange because we haven't talked about hydrates. Basically, that just means that water molecules are trapped within the copper 2 sulfate crystal. But even if you don't know that, you should be able to tell that we have a solid producing a solid and a gas. And so since that gas is produced from a solid, that's got to be an increase in entropy. Number 5b, we have a loss in entropy, or a decrease in entropy, because we have 2 moles of reactants going to just 1 mole of product. And then C, same thing, fewer moles in the products, so we're going down in entropy, becoming less random. Also, you have 2 gases going to 1 liquid. So there you go. Feel free to email me questions if you can't answer, if you can't make sense of this among yourselves in class, and if not, we'll answer your questions. Or if you don't email me, or we don't talk before next time, I'll answer your questions on Monday.